Hello, everyone. First of all, I would like to thank you for attending this session and thank the seminar organizers for giving me this opportunity to present some points of using advanced analytics and artificial intelligence in the mining industry. I'm Soofastaei, an AI project leader in Vale. Vale is the largest producer of iron ore and nickel in the world. We are currently operating mine sites and plants globally, and we are managing an extensive network of railroads, ships, and ports used to transfer our products across the world. The mining industry uses AI right now to optimize processes, enhance decision making, receive value from data, and improve safety. While there are many benefits to its implementation, it is still very new, and there is much work that needs to go into the advanced analytics successful applications. Planning, research, communication, and change management are all essential foundations for analytics implementation in mining. The main part of my today's presentation will be about showing a couple of practical examples of advanced analytics and AI implementation in mining. To use advanced analytics in mining, we need a framework to assess the organization's maturity in different aspects. Today, I will present an innovative and practical advanced analytics maturity framework to evaluate the current situation, clarify the destinations, and highlight the gaps between the as-is and to-be condition. In computer science, artificial intelligence, sometimes called machine intelligence, is intelligence demonstrated by machines, unlike the natural intelligence displayed by humans and animals. From Siri to self-driving cars, artificial intelligence is progressing rapidly. While science fiction often illustrates AI as robots with human-like qualities, AI can include anything from Google search algorithms to IBM's Watson to autonomous weapons. Artificial intelligence today is properly known as narrow AI or weak AI, in that it's designed to perform a little task, for example, only facial recognition or internet searches or driving a car. However, many researchers' long-term goal is to create general AI or AGI or a strong AI, while narrow AI may overtake humans at whatever its specific task is, like playing chess or solving equations. AGI would overtake humans at nearly every mental job. AI technologies can increase business productivity by up to 40%. And it's interesting that the number of AI startups since 2000 has increased to 14 times. AI will automate 16% of American jobs, and currently 15% of mining companies are using AI, and 31% of them say that it is their agenda for the next years. This evidence shows that we will have an AI application revolution in the mining industry very soon. Our company has been active in the field of creative and practical use of artificial intelligence. According to the latest statistics published by official and international sources, only 2 mining companies, Vale and Rio Tinto, are on the list of 50 innovative companies in the world. In the meantime, Vale is ranked 19. This is a remarkable achievement for Vale, and AI Center has played a critical role in reaching this success. As I mentioned before, I'm leading advanced analytics projects in Vale AI Center. In this center, we have a global team focused on advancing the research, development, and application of artificial intelligence across Vale. This center is located in Vitória, a beautiful city in Brazil. Vitória is the capital of the state of Espírito Santo. However, my global colleagues manage the AI projects and developed applications from Toronto, Singapore, Rio de Janeiro, Belo Horizonte, Shanghai, and Brisbane. Our center will act as a focal point where people, technology, and ideas can come together. AI Center works with some key research partners across the world, especially in the United States, Canada, Australia, China, Chile, Sweden, and United Kingdom. Currently, we have a research collaboration with 20 universities with a development plan to reach 30 until 2022. The AI Center research and development model starts with business challenges, and we are working on existing problems and potential solutions to identify opportunities. In the next step, we set the priority for projects based on the concept of the problem and potential benefits. After making a practical plan for each task and in all research models' heart, we collaborate with universities, OEMs, and technology developers to find solutions for the business problems. After solution discovery, we try to test different achieved approaches and deliver the validation results to our partners, same as IBM, Deloitte, Accenture, Oracle, and Microsoft, aim to make the final product. The AI Center works closely with business, universities, research centers, manufacturers, and application developers to deliver the final product for different operation groups across the Valley. When we complete the project, we will start the sustainability phase to finalize a new product. Then AI Center will look after the developed products for any maintenance, modification, and enhancement. In AI Center, we provide the necessary technical infrastructure to support the development, implementation, and operation of AI solutions, including big data infrastructure and data science tools. Moreover, we provide resources and experience in applying AI and advanced analytics globally, provide help as well as the capabilities needed to develop AI solutions. Furthermore, we organize the required training sessions for Vale employees to develop advanced analytics knowledge across Vale. The training sessions can be continuing learning or temporary, same as bootcamp meetings. Also, the AI Center completes the product loop from the initial idea to sustained product. And then we will provide all required related services to make sure the developed products work perfectly for the business. In AI Center, we are focusing on research-based solutions for business problems. We have a big plan to develop an AI application to cover all mine value chain operations. However, our project's scope for a short period has been limited to mining process and maintenance, material transferring by locomotive and railway system, pelletizing and shipping. New projects regarding safety, exploration, and marketing have been added to our active scope recently. Till now, I explained for you more details about the AI in Vale and AI Center, and now I would like to just introduce one of the products that we are using right now in Vale globally. But I should mention, till now, we developed more than 100 products, and this product is just one of them. I selected this one because the initial idea of this application came from my study at the University of Queensland, and I had a chance to test and validate the developed model in different countries for different mining companies. The name of this application is the aim of having this application is increasing the energy efficiency in surface mines, focusing on whole truck fuel consumption. In this project, we had different steps, but was very standard and academic steps. We started from the literature review, and we focused on all published papers, all published business reports regarding to the energy efficiency in surface mines and specifically for haul truck. And then we completed the survey, and we sent the questionnaires to 5 main universities in Australia to be in contact with the professional people who were working directly in the mine sites to find the key effective parameters on haul truck fuel consumption. We identified more than 35 effective parameters, but we couldn't make a model to cover all of these parameters. So we selected just a limited number of the parameters. We made a prediction model based on artificial neural network to predict the fuel consumption and gas emission by truck based on first 3 parameters, and then we extended to 10 parameters. When we developed this application for the mining companies, the result was very, very exciting and said, okay, Ali, you did a great job, but now we can predict the fuel, the consumed fuel by truck or the gas emission. But the question is that how we can minimize this fuel consumption and gas emission. So I added another project to the previous one, and we use genetic algorithm to optimize the key parameters to minimize the fuel consumption. And then I wrapped up this product, including the ANN model for prediction and genetic algorithm for optimization, and we developed a product. The initial product developed by the University of Queensland, and I started using this application for PHP. But later, when I joined to Vale, I extended this model, and now this model is working as one of the key AI center products in different mine sites in Mozambique, in Brazil, in Indonesia, and in Canada. As I explained for you, we have 2 different types of analytics: the classic analytics or classical methods, and advanced analytics method. When we are speaking about the classical methods, we are speaking about using the regression, using some normal statistical methods to reach to the insights from the data. But when we are speaking about the advanced analytics, we are speaking about the machine learning, AI, and something like that to predict, optimize, and making decision. As I already mentioned, when I completed this application at the University of Queensland, I started testing this model in different countries, in different mine sites for different products. I had a chance to test my model in Australia, in China, and in the United States. And as a result of the initial model, you can see something here that we tested in Cerrito mine site in Arizona, and you can see for fuel consumption, we reached to 3.3% of improvement. And at the same time, we reached to 2.4% productivity improvement, because this application was an integrated model. We not only could reduce the fuel consumption, but also at the same time, we could increase the productivity by controlling the payload variance and some other effective parameters. We tested the model in Kayenta mine site in Arizona again, and we reached to the 4.6% of fuel consumption improvement, and the productivity improvement was 3.22. These applications tested by the data collected by Peabody Energy in Kayenta mine and from Freeport McMoran in Cerrito mine site. In Australia, we tested this model for BHP in one of the biggest coal mine site in Asia in Blackwater. Blackwater mine site is located in central Queensland and is one of the key coal resources in Australia. And for fuel consumption, we reached to 8.3%. I should mention that we tested this model and this application for different haul trucks. For example, here we tested for Caterpillar 798. But in other sites, we tested for 777 and other Caterpillar. In Vale, we tested on Komatsu as well. And you can see the results of Morenci mine site as well. The fuel improvement was 9.1 and the productivity improvement was 4.2. This is the latest results of this AI application in one iron ore mine site in Brazil named Carajás. And in the left side, in this slide, you can see the actual data for fuel consumption before using this application. And you can see the indicator FC index. FC index or fuel consumption index is the specific indicator that we designed for this product. And the unit of this indicator is liter per hour per ton. It means that how many liters of diesel should be burned to move 1 ton of mine material in 1 hour. And as you can see here in the right side, by using this application, we could reach the fantastic results. And we reduced the fuel consumption by haul trucks in the fleet, in the whole fleet, to up to 6.6%. And at the same time, we could increase the productivity up to 5%. But in this application that we developed for haul trucks, we focus on fuel consumption. But as you know, we have a lot of problems when you are focusing on just one aspect of the problem. As an example, maybe we could reach to the good results for fuel consumption and when we minimize the fuel consumption. But in other side, there is not any idea about productivity, maintenance costs, safety, and etc. So the problem now is that how we can make an integrated model to cover all aspects of this problem, not just focusing on one specific, for example, fuel consumption. We selected 4 main groups. You can see the operation, maintenance, fuel consumption, and environment. Environment specifically means the gas emission. So we try to find how this type of AI model can help us to increase the benefit minus cost. We named margin here. By covering the operation, maintenance, environment, and fuel consumption at the same time. But as you know, it's a very complex problem. For example, for operation, we are facing with some source of the data and information coming from the people, from fleet management system, from road conditions, from machines design, mine planning, weather, and fuel quality. And for each box here, we have a lot of parameters. And we need to manage all of these parameters if we want to develop an integrated model. For maintenance, we have same problems because the maintenance information is coming from the road maintenance, from oil quality, from machine maintenance, and etc. If you want to calculate the maintenance cost and find the effect of maintenance cost, find the effect of these parameters on maintenance cost, you should cover all of these aspects. For fuel consumption and environment, we have other resources of data and information, but we could reach to the integrated model and we merge all of this information and data sources together to not only increase the fuel efficiency or energy efficiency, but also reduce the maintenance cost and increase the productivity at the same time. And in this project, we had different steps, different 3 steps: prediction, optimization, and making decision. In prediction, we could help the mine managers or supervisors to predict the productivity, to predict the gas emission, to predict the fuel consumption, and to predict the maintenance cost before happening in different windows. For example, next week, next month. And also we could help them to receive some advices from application to increase the productivity, increase the energy efficiency, and reduce the maintenance cost at the same time. Later, I will show you how this application can make this type of advices. But this is just 2 parts of this project. The last part is very interesting, is related to the decision making. We try to replace the human by machine. So we try to receive these advices from machine and then deploy this type of advices practically by computer. But as you know, in some cases, we need human to supervise the conditions, but in more than 80% of the decision made by computer is more better than the human decisions. This is an integrated model that I explained for you. We covered the operation, maintenance, and fuel consumption, gas emission at the same time, and we reached to the optimized parameters or controllable parameters to have the improvement. This integrated model had 3 sections I explained for you: the simulation or prediction, the optimization section, and last one, the decision guidance. In the beginning of my presentation, I explained for you that right now we don't have access to the strong AI or general AI. We have just weak AI. In the weak AI, we can just predict and making some advices for the human. But we hope in the close future, we can have the general AI or a strong AI to deploy the generated advices by machine practically in the mine site. But we are very young in this field, but I believe that we are very close to reach to this aim. Here you can see the dashboard of developed application. Is a very simple dashboard, and we have 3 sections in dashboard. The current application can cover 10 effective parameters to reduce the fuel consumption in the mine sites. And in the first column, in the left side, you can see the results of the simulation, which means that by having access to the data lake and capturing the data, historical data from the fleet from the site, the application can predict the consumed fuel by each truck individually. In the middle, you can find the optimization section. By press just one button, the application can optimize these 10 parameters to reach to the minimum value for the fuel consumption. And in the making decision part, in the left column, you can see the list of the created advices by application. You can select one of them, for example, reduce the whole truck speed, and by press the button, you can see the effect of this decision on maintenance costs or productivity, and also we have something about safety. The application can find the risk of this decision, the low risk, medium risk, or high risk. And then we use the traffic lights to select the advices. If the application show you the green light, means that everything is okay and you can make this decision, and the application can guarantee 100% this decision works for you. yellow light shows that the application needs the human decision in this specific case. And the red light shows that the application suggests you to avoid making this decision. This application works for machine, but in other side, we can use this application for coaching. It means that we not only will have access to the truck behavior and we can control some parameters for truck, but also we'll have access to the driver behavior and supervisor behavior, and we can have some advices for the people as well, and we can coach them and we can help them to increase their capabilities in the future. For example, here you can see the one dashboard of the application, and you can just select the date and you can select the shift. You can see the name of the shift manager, and in the top you can see the goal for productivity, and you have the list of the trucks here in different color. For example, green, orange, and in some cases red. Green means that the truck performance is very good. There is not any advices for this truck, and you don't need to change anything. For orange one and for red one, the application has some advices for you to have a better performance. By click on one truck, you can see the profile of the truck, something about the truck identification, and also you can see the average fuel consumption by this truck. But we have different colors and different curves here to show the historical condition for the truck, and also the predict something for you in future if truck continue working in the same conditions. And for people also, you can just select one and you can click on one people, including the shift managers or drivers, and you can see the results of application for these people. For example, some parameters that are controllable by the human have been illustrated here. This guy is a driver, and you can see the driver behavior, the effect of driver behavior on fuel consumption, on loading queue, dumping queue, payload distribution, and something like that. So this application can predict the driver performance if he or she continues his previous behavior. But this application can make some advices for the people to increase their performance. For example, here you can see the list of advices for this guy. His name is Alex. Average loading queue time is okay. Average dumping queue should be decreased, and average payload should be decreased as well to reach to the best performance. But as you know, this is the trained application. This is the AI application, the intelligence application. It means that for each second after receiving any new data, the model has this capability to retrain itself and then provide the new advices for the people. It means that the advices will be changed every day, every shift, or every week. We have same story for the manager, and you can see the list of the parameters, controllable parameters by the shift manager. We have the mobile version of this application as well. You can install this application on your smartphone, and you have access to different parts of this application on your phone. We have different access for managers, for drivers. We already logged something for the people. And also you have access to all of capabilities that I explained for you in the desktop version. Everything is available on the mobile version. And you can see the advices for the people. For example, Rodrigo here is a supervisor or shift manager, and you can see the list of the people who are working with him, and you can see the generated advices by application for Rodrigo to advise the people to how to reach the better performance. And also, this is the score of the people. The application has this capability to score the people based on their performance. It can be the good idea for any award or any promotion for the people based on the score. And also you have access to the profile of the people, and you can see their licenses, their score. In this case, for example, Juan working on the excavator, loader, and truck, and you can see his performance by a star illustrated here in his profile. And other capabilities, then you can print and you can extract all of the information as a report, different types of the report in the site, using the desktop version or using the mobile version. This generation is a new generation of fuel consumption application. We developed this application by one startup in Chile and one startup in Australia, Indimin in Chile and artificial learning intelligence in Australia. Vale right now doesn't use this application, but we have a plan to make this application for Vale as well. But we could cover just the whole truck in this case, but as you know, this problem is bigger than the truck, bigger than the hauling, because we have upstream and downstream operations. By changing something in the hauling, definitely many things will be changed for crushing, or in upstream for loading, for drilling, for blasting. We will face some new challenges. To cover all of these challenges and make an integrated solution, we offer the new application we named M2M, or mine to meal, and we try to make a connection between all previous developed AI application for drilling, blasting, loading, hauling, and crushing together to make a comprehensive application. But this is the new idea again in Vale, but we already signed an agreement between the University of Queensland and the AI Center in Vale to use their experience and knowledge to make this application for Vale very soon. We have reviewed a practical example of advanced analytics and AI business application, but we need to know how we can take opportunities and minimize the challenges and costs to use AI products in mine sites. One of the best developed approaches in this field is the AI maturity framework. The first idea to develop this innovative framework came to our research and development group at Vale AI Center in 2019, when we developed different AI products for various mine sites, but the main part of them were not scalable. The design products worked very well in the particular sites that AI models were specifically made for them. However, we couldn't use the models in other mine sites because the mine site conditions are completely different in different sites. To solve this issue, we could develop a sophisticated maturity assessment framework to evaluate the site conditions in different dimensions. The aim of developing the framework is to provide an approach, a methodology, and set of reusable tools to guide the development and use advanced data analytics in a maturity matrix framework that recognizes and models the cross-functional, multidisciplinary requirements to use advanced analytics effectively. Generally, there are 6 main steps in analytics maturity, starting from raw data and finishing with optimization and decision models. Analytics, science, and technology have been developed significantly. However, the main part of modern industries, such as mining, is located in a sense and response zone. The main reason for this problem is slowing maturity in data, people, system, and processes. Making action based on the prediction can increase the quality of products and services and decrease the final cost, including raw materials, maintenance, and energy consumption. Increasing the analytics maturity level can also improve safety, reduce equipment failures, and unexpected shutdowns. This slide shows a radar diagram as an assistant to evaluate the analytics maturity in 4 main groups of dimensions. These groups are system, data, people, and process. The details of each group's dimensions can identify by organizing the workshops with business specialists in each company. For example, here you can find the results of the design thinking session on surface mine site to clarify the definition of each dimensions individually. This framework suggests using 6 levels of maturity for each dimension. These levels are exactly the same as the analytics maturity level that I presented in the previous slide. You can find all these 6 levels with different color from dark orange to dark green in this slide. We need to reach a particular maturity level in each dimension separately for each advanced analytics and AI project. By connecting these level points, we can draw a spider diagram named to-be diagram. In this slide, the to-be situation has been highlighted by purple line. On the other side, by evaluating our company's current situation, we can have an as-is diagram. Please see the red lines here is an as-is diagram. The difference between the red and purple points in each dimension shows a maturity gap between the as-is conditions and to-be situation. This assessment should be completed before starting any analytics project because by clarifying the gaps in all dimensions, we can have a better vision of cost of analytics to compare it with the project's potential benefit. The maturity assessment can be completed at a higher level. This type of evaluation defines the new groups of dimensions to cover data, process, people, and system for higher investigation. This assessment can be completed for safety, operation, maintenance, and energy consumption. The executive managers need this type of assessment when deciding to allocate the budget to different projects. Having a high level analytics maturity level scale can also help make a maturity balance between different companies' improvement. Analytics maturity assessment can also use a tool to complete internal benchmarking. When a company has different assets and a limited budget for improvement, managers need to allocate the right budget to the right asset. As an example, in this slide, you can see the results of the low and high level of maturity assessment for all groups of dimensions in a mining company. This assessment has been completed for a specific project named Project A. As you can see here, we have the maturity assessment results for data, process, people, and system. This evaluation includes the operation, maintenance, safety, and energy consumption. In this assessment, 3 mine sites have been evaluated. The different mine sites have been labeled by the different color. Mine 1 is green, mine 2 is purple, mine 3 is brown. The maturity assessment results for Project A in this company show that there is no maturity balance between the mines, and there are many unbalances in each mine individually. In summary, it is obvious that Project A in this company with this condition cannot be successful project. In the previous slides, I tried to explain the structure of the maturity assessment approach in a simple form, but In reality, this method is complicated, and we need a comprehensive investigation. In Vale AI Center, we already developed a platform to estimate the analytics maturity for different assets in different areas. This slide shows a screenshot of the dashboard of this platform. We can see here that we have access to the analytics maturity assessment results for 4 main dimensions in different regions. We also have access to the details of this assessment in each mine site and plant individually. This application can help management to make a better decision to develop AI applications in Vale globally. Okay, at the end of my presentation, I would like to introduce an innovative platform established especially for mining researchers and managers to share their ideas and experiences in advanced analytics and digital transformation in mining globally. This platform aims to create a community of researchers in artificial intelligence and advanced analytics to provide an opportunity for further collaboration in future digital mining projects. We can also keep in touch with each other on the websites, groups, and forums, and be informed about the latest research. Please join us on the to start a fantastic journey to mining industry 4. Thank you so much for your time.
Awesome. Thanks, Vale. This was a really interesting talk, and we already have a number of questions in the chat box. I really appreciate your time and presentation. It was a neat go through of a step-by-step process. But since we are in short of time, since you have to leave, I'm going to go ahead with the Q&A session quickly. The first one is on the hot truck energy efficiency you were talking earlier, and how does the system adjust its advice based on meteorological or road conditions? Jim has asked this question, and how the performance compares to automated haul truck driverless ones.
This is a good question, because when we developed this application, we didn't have the fully automated system or the autonomous fleet. But right now, for example, Vale working with Komatsu, and we already developed one autonomous fleet in Brazil, and we have other autonomous fleet in Australia. This application not only can use individually in the mine site, and we are feeding this application by data coming from the developed platform by Komatsu or the Caterpillar, same as MineStar. But also we can use this application to help the autonomous fleet platform to make a better decision to control the truck. For example, control the speed of the truck, because right now The developed application, same as MineStar for autonomous fleet, can control the speed of the truck to avoid any truck bunching in the fleet. But the aim of those applications is just reducing the queuing in the fleet to maximize the productivity. But this application not only can help MineStar to reduce the queuing time, but also can help to increase the energy efficiency, reduce the gas emissions, and also reduce the maintenance cost. We can cover the autonomous fleet platform by having this application. And I think the first part of the question was about the road conditions.
Yeah.
This application has been equipped, by using some data coming from the sensors in the truck to estimate the road conditions. We are just focusing on the slope of the road right now because we have the total resistance for this application. Total resistance is the rolling resistance plus the grade resistance. For rolling resistance, this application cannot cover anything right now, but we are working on that. Hopefully in the future, we can add this feature to the application. But for the slope of the road, this application can help the road maintenance team to have a better grade for truck in different sections of the road.
Awesome. Thank you. There's a question from Foster on your model. So are your algorithms primarily supervised learning with labeled data? Does unsupervised learning have a role here?
Sorry, the label data or labor data?
Label. Is it supervised learning? Do you have already data which is categorized and labeled?
Label data. So yeah, we have this application that we developed using the unstructured data, and we use the ANN, for example, to do for this. But yeah, we use the algorithm to label the data and making the category for the data to have a better results of that. But if you are interested to know something about the details of the structure of the models or the data or something like that, I can refer you to go to my website that is here, and you can download 3 published papers in this field. And in the papers, I explain the structure of the data collection, data preparation, and the developed model. Or you can just go to the Google Scholar and you can just search my name and you can find the list of the published papers in this field. And please feel free to be in contact with me if you need more technical information about it, the models and data.
Thank you. There's another question on the haul truck thing. Is there a specific tool platform to do an evaluation, either assessment to verify the current maturity of the companies to AI and analytics?
To start using this application, as I mentioned before, we have the maturity assessment processes, because using this type of the sophisticated model needs the good quality data, and we need to train the people before using that application. So we have one application to assess the maturity before using this application. Okay, we need to make sure your mind side has this capability to use this type of application. If not, we can have some recommendation for you how you can reach to this level of maturity. But if you are speaking about the developed product, this developed product can use individually, can install on the current platform for dispatching system in the control room, or it has this capability to add as a feature of other platform that you are using normally, same as modular or MineStar in the mine site.
Makes sense. Thank you. There is one more question on the model, might be very, very detailed, but let me try this. What are the hyperparameters that controls the model? And what is the neuron density of the model? Is the model generalized for any mining operation, or is it overfitted to each mine by special mine characteristics? This is a question from Lee, and it's a little overloaded.
So this application, this application has been generated to use the general information and data that right now is available in all mine sites. We don't need some specific parameters. We are focusing on 10 popular parameters, for example, truck speed, the grade resistance, payload, and so on. All of this information are collectible normally in all mine sites across the world, because when you are using Caterpillar, when you are using Komatsu, when you are using Balas or other brands, they already developed this type of application to collect this information and data. So we try to make a scalable project, a scalable product, and you can use anywhere, anytime. But we need some modification or enhancement if you want to use this application specifically for one site. Maybe we need to retrain the model, maybe to define some boundary for the parameters and so on. But it takes just a couple of weeks to adjust the current product for any specific mine site.
That's great. In interest of time, and I realize you have to leave in another 5 minutes for another meeting, I would like to conclude the Q&A session now, and I really appreciate you coming down here and talking to us. The talk was very interesting, and I'm glad that you touched upon a lot of case studies and how we can integrate in our mine activities where with the existing data and existing operations and making something new, and if we need, where we can go ahead and build up the infrastructure needed for that too. A couple of points before we leave. We have the new tailings center pitch by Dr. Nelson. I will just have a quick repeat on the chat box for you to look at it. And also, we have an interesting talk coming next week called The Vertical Attack, and it's not at the usual 4 p.m. time of Mountain Time. It's at 10 o'clock in the morning. We are having this company from Germany who are building hydro mills, trying to see how vertical excavation is possible and the expansion of that from the civil industry. Hope we all can see you there, and thanks a lot to Dr. Soofastaei for joining us today, and we hope we can have you here in future in person when things settle down and do some more collaboration work with what you're doing. It's really interesting stuff. Thanks a lot.
Thank you so much for giving me this opportunity to be with you today. Thanks.